So hello everyone, this is Pradhan Shrestha, and this is an assignment which is Introduction to Software Engineering, Multimedia Presentation and Professional Engagement. So this is the second part, and I have discussed about software engineering, its continued relevance, the software, uh, the, the results of software engineering in my first part. You can check that out too. So here the agenda is we will compare about software methodologies, which are Waterfall, Agile, DevOps, CI/CD. We will also discuss about the methodology impact on project cost and delivery speed, unique challenges faced by software engineers, and what happens when software compromises quality, and the engineer's responsibility beyond budgets, and also the consequences of negligence in the real world. Okay. So first of all, software processes and methodologies. Software development methodologies are structured frameworks that help to guide team planning, executing, and delivering software projects. The choice of choosing a methodology has a great impact on project success, team productivity, and business outcomes. Each approach offers different advantages depending on project requirements, team size, and organizational culture. Okay, so some of the popular methodologies are Waterfall, Agile, DevOps, CI/CD. Okay, so first of all, let's talk about Waterfall. Okay, so Waterfall methodology is a sequential project management approach that includes phases, each covering a separate part of product development. So Waterfall is a sequential approach. So a new phase cannot be started until completing the previous phase. Due to this rigid approach, it is difficult to implement any changes after the phase has been completed, thus it is not suitable for complex projects. This approach requires clear documentation of the requirements, and the timelines and budgets are quite predictable. Okay. It is best for projects with fixed requirements, regulatory or compliance heavy environments, and large scale enterprise implementations. For example, NASA successfully uses waterfall methodology for space missions, where the requirements are defined and changes are costly or even impossible once the development of the project starts. Okay, so the next one is Agile. So Agile is a popular methodology. So it is a repetitive project management approach which is quick and easy for both small and large projects, and includes customer satisfaction. This methodology is often used in cases where the requirements are changed frequently. It is an iterative process where developers work in sprints, where a sprint is basically a time frame of about 1 to 4 weeks long, where requirements are gathered and the development team works to complete a specific set of prioritized tasks. This approach requires flexible scope and requirements, regular customer feedback cycles, and cross-functional team collaborations. Agile includes processes such as sprint planning, where we define goals and select backlog items, development, where we actually build features, review. So after each sprint completion, we demonstrate the completed work to stakeholders, and after getting the feedback from the stakeholders, we improve the software accordingly. So, for example, the Spotify model, an independent, popular, people-driven strategy that scales agile principles by prioritizing culture, communication, and a network structure, is the foundation of Spotify's growth and success. Okay, so Spotify uses agile methodology and they call it Spotify model. So with the help of this model, cross-functional teams are grouped into squads which resemble mini startups and are given the freedom to select their own techniques, okay, and features, allowing for efficiency and quick iterations. So these squads are grouped into tribes for alignment. Together, these groups foster high transparency, team autonomy, and faster customer value delivery. Okay, so the next one is DevOps. So DevOps stands for Development and Operations. It is a collaborative culture which outlines a collection of ideas, practices, and processes and technologies that help streamline product development. It focuses on effective integration and collaboration between development operations teams, motivating them to focus on the delivery of high quality products. So the motive of DevOps is to break down the barriers between engineering and operations team through cross training and smooth communication channels. Okay? So its aim is to make sure there is minimum disruption and maximum benefits. So the benefits of including DevOps includes enhanced agility, automation, collaboration, efficiency, detecting early errors and fixing bugs, reducing risks of miscommunication and misalignment, and finally improving user satisfaction. So for example, thousands of technical teams such as Microsoft to build products such as Office 365 were able to deliver continuously because of Azure DevOps, which cut down development times from months to minutes. Okay, so the next one is CI/CD. The CI/CD stands for Continuous Integration and Continuous Delivery. It is a collection of principles and practices which is designed to assist development teams to ensure the reliable delivery of frequent code changes. It helps engineering teams to integrate their work frequently. Previously, integration was an expensive activity that required lots of back and forth among different teams, but now continuous integration drives the adoption of automation tools for testing and building. For instance, Jenkins, which is an open source automation server, is one of the most popular CI/CD solutions. So, some of the advantages of CI/CD pipelines include fewer bugs in production because of automated testing, simplification of the release building process, easy bug detection, reduction in testing cost due to automated testing. So for example, every day nearly thousands of deployments are made possible by the microservices architecture with CI/CD. Their method accelerated feature delivery and cut downtown downtime by 90%. Okay, so the next one is how methodologies impact project cost and delivery speed. The key factors in choosing the right software methodologies are project complexity and requirement stability. Okay, so waterfall. So waterfall reduces the risks of rework on large unpredictable systems by pre-planning for stable requirements in complex systems. While the delivery is slow because of single release, the structure is focused to lower overall project cost by avoiding scope creep, for example, going into illness requirements so in the execution phase. So Agile, it is useful to minimize costs and accelerate delivery speed by adapting to changing requirements and focusing on simple projects. If the project has several changing requirements and delivery is on a specific time frame, Agile is best suited. Okay, so DevOps decreases the operational cost of deployments and increases delivery speed by focusing on complex projects and establishing cross-team collaboration. It decreases the deployment pipeline through effective communication between development and operations team. CI/CD. So it emphasizes fast delivery of systems due to its continuous integration and delivery model. By automated testing and release process, it drastically reduces deployment time and reduces the errors that arise while manual testing. Thus, when projects require continuous delivery with many test cases, this approach can be very beneficial. So to conclude, what I like to say is there is no one software development process that is effective for all projects or organizations. Okay, every methodology has its own advantages and disadvantages. The key to success is matching the approach to one's specific needs. They can use one or more methods in a single project. Okay, so unique challenges in software engineering. Um, okay, so let me it's a unique challenges. Okay, so software engineering So software engineering has a lot of challenges. Okay, so software engineering at its core is a constant negotiation with complexity. From the initial phase to deployment and maintenance, engineers have many challenges that demand technical powers and a deep understanding of their professional and ethical responsibilities. So, number one is complexity. Now, the software systems are complex. They are made up of countless interconnected components, each with its own logic, dependencies, and potential failure points. Due to this, it is a challenge to design, implement, test, and maintain. Because of this behavior, systems can be unpredictable, leading to unexpected vulnerabilities. Hence, managing requires rigorous methodologies, modular design, and a strong and detailed design. Okay, so conformity. Software systems frequently function in accordance with user expectations, legal requirements, and industry standards. Another level of complexity arises from the need to ensure consistency across different platforms, devices, and user demographics. This includes the following performance standards, data privacy laws, and accessibility rules. Legal consequences, harm to one's reputation, and user disconnect can arise from non-conformance, which emphasizes how important it is to have comprehensive compliance plans and testing. Okay, so the next one is changeability. The software industry is always changing. As technology develops and user expectations change, so do requirements. Software must be built to adapt these changes gently without generating new problems or disrupting existing functionality. This means having flexible structures, adaptable code bases, and a dedication to continual reworking and improvement. Inability to control uh, change can result in fragile systems that are costly to maintain and rapidly become outdated. So it is very important, the software, the technology we use, uh, the things we use to build a software, it can adapt to the changing environment. Security is one of the most important aspect. In an increasingly digital and interconnected world, software security is an important concept. The systems are under threat from malicious code and viruses which can exploit vulnerabilities, leak data, or disrupt services. It is a crucial job for developers to make sure the system is secure and safe through secure coding practices and regular security audits. Security is so important that a single security breach can have destructive consequences which can affect financial loss of trust from the clients, the public, and so on. So the next one is what happens when cost cutting compromises quality. So it is true that the software has a lot of technical challenges, but also software engineering is deeply connected with ethical considerations. Software which is developed with every line of code, architectural decision has the potential to impact individuals, societies, and the country at large. So it is a huge responsibility for software engineers to uphold ethical principles and ensure the work solves the greater good. Okay, so number one is budgetary constraints. The constant push to cut costs and shorten development times is one of the most destructive challenges to software quality. Driven by financial goals or market needs, project managers and stakeholders may advocate for shortcuts that omit important phases of development. So, skipping test phases. So, in order to cut costs, there are also compromises in the testing phase. Skipping unit tests, integration test, or user accelerated testing, which is also known as UAT, can have immediate costs at can save immediate costs at present, but in the future it results in high risks of undetected bugs and vulnerabilities. So the next one is ignoring technical depth. Another measure of cost cutting is to defer refactoring or addressing technical depth. Though skipping this process saves time in the short term, it accelerates difficulties in the form of increased maintenance costs, reduced agility, and a higher chance of future failures. So the next one is inadequate resourcing. to save salaries, creating a small team or assigning tasks to underqualified personnel can severely impact quality. Overworked or inexperienced team members are more likely to make errors and less likely to produce robust, well-engineered solutions. So, ethical dilemma. For engineers, these cost-cutting strategies pose a serious ethical and moral problem, which is should they put short-term financial objectives ahead of maintaining safety and quality standards? Software with serious defects may be deployed due to financial pressures and unavailability of time, which puts users or vital infrastructure at risk. So therefore, the cost-cutting techniques can seriously compromise the quality of the software. Okay, so ignoring the software quality to cut costs can result in serious hazards in the future. To cut costs, deploying the software without proper testing, using a less skilled team, making delivery time shorter without proper planning can result in deploying the software with less budget at present. However, in the future, in the maintenance phase, it results in higher maintenance costs, damages client and stakeholder trust, and introduces possible security threats. Thus, it is very important not to compromise on software quality as it can result in serious disadvantages in the future. So, to cut the cost, uh, the 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 organization can hire junior developers or even skip the test phase. Yes, it can save money and time at present, but in the future that can be very costly. So it is very important to properly develop and deploy the software so that in the maintenance phase uh, so that in the maintenance phase uh, there there can be less hazards. So it is very important to do that. Okay, so what are the engineers responsibility beyond budgets? Okay, so software engineers play a vital role in budget allocation of the software. However, they have a lot of responsibilities except for budget allocation. Some of the responsibilities are advocating for quality. Software engineers play a vital role in advocating adequate resources, time, and processes necessary for delivering high quality software. They are responsible for managing the necessary resources to have smooth software development, deployment, ensuring reduced maintenance costs. This includes clearly communicating the risks associated with shortcuts. So prioritizing user safety. Software engineers also has the responsibility to make sure the software is safe to use. So this is one of the most important aspect. And the next one is maintaining professional integrity. Maintaining professional integrity refers to refusing to compromise on established engineering principles, especially when pressurized by the stakeholders. This shows a culture of accountability and excellence. Considering long-term impact. Software engineers should consider the long-term impact on society, environment, and on the ethics of the software. The system should be fair to everyone and should have no negative impacts. Okay, so the next one is consequences of negligence on the real world. So the result of compromised software quality is not merely theoretical. Compromised software can have severe consequences in the real world, such as widespread data breaches. Okay, so and if the software is related to a medical device, then medical device malfunction, critical infrastructure shutdowns, major financial market crashes, military defense and security vulnerabilities, etc. Such incidents cause real-world problems and result in a loss of trust in software engineers. So, so it is very important to not neglect anything while developing a software uh, because there are and because there can appear severe um, consequences while if they do this. So it is very important, very important to uh, make sure the software is good and and the software is so it is very important to make sure the software is good, working fine, and has no negative impact whatsoever. Okay, so yeah, if you have any questions you can ask me. And thank you so much for listening.